So hello and welcome to our session today to discuss our point of view around the shift culture that's permeating the software testing industry. My name is Don Jackson. I'm a chief technologist here at Micro Focus, and I'll be leading our discussion today. You may have heard of shift left or shift right being essential to successfully preventing defect slippage in today's application development landscape. In fact, the 2021-2022 World Quality Report cites that 55% of respondents stated that they need to shift left more, and 53% of respondents stated that they need to shift right more. Our session today is going to focus on the Micro Focus point of view that we need to shift everywhere, both left and right, but not abandon the lessons we've learned so far in testing. Gone are the days of being able to toss the application over the fence to QA once you finish coding. The speed of business is too fast to allow for the delays introduced through feedback being sent days to sometimes weeks after the developer finished the code. The human mind has such a challenge context switching from what is currently in the forefront to what was being worked on that long ago. That delay is further compounded by having to ramp back up on what the developer did prior to the commit. IT has provided a solution to this, and that's delivering software through a DevOps pipeline. But what is a DevOps pipeline? A DevOps pipeline can be visualized through a water pipeline. There are gates represented by the valves at different points. And if a failure occurs, represented by the production feedback at the bottom, feedback is sent back to the submitter, usually a developer, immediately to reduce the likelihood of context switching delays. The submitter then resolves the failure, then resubmits into the pipeline. When the submission occurs, it should be stored in a source code repository. That source code repository should version the changes, including submitter comments, provide collision detection, which is if multiple changes against the same source needs to be integrated from multiple submitters, and merging capabilities to handle those collisions. Once the source has no collisions, the build system should take over and start executing the pipeline steps. This is part of what we call continuous integration. The first step is to compile the source code to create artifacts, like say a jar file for Java code, and then store those artifacts in an artifact repository. Once the artifacts are copied to the artifact repository, which provides a central location for all artifacts, the build system then executes unit tests in the testing system. This is part of continuous testing. Assuming that the unit tests pass, the build system then engages the provisioning and deployment solutions to stand up the next pre-production environment, then deploy the artifacts to that environment. This is part of what's called continuous delivery. Once the environment is up and running, the new artifacts, the testing system then executes the appropriate automated tests for that environment, the other part of continuous testing. The build system then has the provisioning system deprovision the environment. Those last three steps are repeated for each environment or type of testing that needs to be done. For example, integration testing or environment, system testing, performance, etc. Once all of the testing is completed successfully, the build system has the deployment system move the artifacts into production, including any steps necessary to have that application start to leverage those new artifacts. That might include things like JVM restarts, full system restarts, cache cleanups, or other things like that. That's called continuous deployment. As part of the deployment, the operations or monitoring artifacts, the scripts, configurations, alerts, stuff like that, are deployed and activated. These should also have been included in the lower environments, and that's part of continuous monitoring. Now that we've set the stage for what is a DevOps pipeline, let's drill into testing, which is what we're here to talk about. We talked earlier about the reason why we can't just throw stuff over the fence to QA, but that doesn't mean that the QA persona is no longer needed. The QA person provides a critical and different way of thinking to how to test a solution. QA has a destructive mindset. They are the resource who will come up with and execute in an automated way the majority of the negative test scenarios for the artifact. A good example of this might be a quantity field on a shopping application. Positive test, which should be handled in unit testing, would be to test the boundaries of the field. Let's say it's a 2-digit field. So the data scenarios covered by a positive test would be the boundaries, the lowest, 1, the highest, 99, and some random value in the middle. This would satisfy the unit test and the positive test. The QA person, though, would come up with negative testing scenarios for data. Things like entering in 0 or entering in -1, or trying to enter in 999 billion, or trying to enter in the pound key or some Cyrillic value, or pasting in as an emoji, things that could potentially happen in the real world that might cause the system to fail. While QA provides this necessary and valuable insight, there are definite limitations to what QA can do. Normally, QA is doing black box testing, meaning that they have no visibility into the inner workings of the artifact and thus can't ensure proper code coverage. Further, QA is typically engaged, as we discussed earlier, later in the cycle, increasing the time for failure feedback. This is why we need to include the dev tester, or the software development engineer in test, SDET, or the developer into the testing. The dev tester should be focused on unit level testing. And because they're the ones typically writing the code, they'll be doing what's called white box testing, meaning that they can validate the inner workings of the artifact, all the logic permutations, all the different case statements that you can go through. They also have immediate feedback, so no delay or context switching problems, which we talked about earlier. This graphic helps visualize the way shift left and shift right are viewed, with the developer testing being as far left as possible. You could also visualize the shift left, by thinking about the positioning of activities on a Gantt chart, like in a project plan, with the development activities happening much earlier, or left in the Gantt chart. While the developer understands the code and they can ensure adequate code coverage and get the fastest feedback by creating and executing tests themselves, neither development nor QA has intimate knowledge of how to run the business utilizing that artifact. This is why it's crucial to also shift right your testing by engaging the business analysts or the domain experts in the testing, with them contributing to the test automation. This persona is the person or people who understand the business processes, why the artifact is being built or modified, and how that artifact will be leveraged to run the business. They know the flow through the business, understand what's critical to keeping the business going, and what workflow will be executed through the solution utilizing this artifact in question. This person typically does not know how to code and can even be scared off from doing work if shown code. They might run for the hills screaming, actually. This persona typically doesn't, as I said, doesn't know how to code. It's critical, though, that their contribution towards automation doesn't require coding skills, yet they can still contribute to that automation. When you think of this persona, you can think of like a banker at a bank. They have little to no technical knowledge, but their contribution to their business knowledge into test automation is crucial to getting as close to zero defect slippage as possible. We at Micro Focus provide solutions to all three of these personas. In the functional test automation space, the QA persona, we provide a solution called UFT1. This solution is infused with our AI model, providing computer vision and OCR capabilities to the QA persona, enabling faster scripting and more resilient tests than the property-based scripting that we've used for the past 20 plus years for test automation. Essentially, computer vision identifies the objects on the screen the same way a human does, by their visual characteristics. So like for a shopping cart, you could think of that as it's like a half of a hexagon, and it might have a line underneath it. It might have two dots representing the wheels, and it might have a little squiggly line to the side to represent the handle. That's the visual characteristics, not the properties. This screenshot shows the AI inspection window where the computer vision has identified multiple objects and text blocks on the screen that can be acted against. For the developer, we provide UFT Developer. UFT Developer is also infused with the AI model, but is delivered via libraries in the developer's native IDE where they want to work. In this case, we're displaying IntelliJ, but since they're libraries, they could be imported and leveraged into any IDE that supports Java, JavaScript, or C#. If you're using Visual Studio, Eclipse, IntelliJ, the Spring Tool Suite, JBoss Developer Studio, CodeReady Developer Studio, or Android Studio, you also get the benefit of the UFT Developer menu that you might be able to see at the top if your eyes are really good. And their associated wizards can help developers be even more efficient in their test creation and maintenance. UFT Developer also includes a local version of service virtualization at no additional cost for the developers to leverage, enabling to test the artifacts when the other components in the solution aren't available. For the business analysts, we provide a solution called Codeless, which is in technical preview and comes with UFT1. As you can see, the script, air quotes script, is in near plain English. No business analyst should be scared of a step that says, click the profile, or click the speaker's text, or type the username data into the user field. This is also leverages that same AI model. In that AI model, we also have what I like to call an analogous words engine. So if you created a script off of a mock-up and it said login in the mock-up, and when they actually implement it, they change it to be sign in, it treats those two phrases as the same for OCR capabilities so that you can not have to modify your script. It just adjusts the confidence level. We've equipped UFT with AI technology as follows. First, by using computer vision to identify the elements the same way a human does, not the traditional way of using the underlying identifiers or locators. We also use a neural network that understands the element so that you can make a decision of how to natively interact and manipulate that object. So if you think of a search button, for example, the magnifying glass, a native way to interact with that is you and I understand. You click the search, you have to type in a value, and then maybe you click the search button or hit the enter button to execute it. That's natively, naturally interacting with that object. We've also embedded the NLP capabilities that we talked about so that the test can be written in almost plain English. And we've leveraged the power of our install base to also provide a feedback mechanism for each of these personas so that they can send feedback directly from the tool so that back to us so that we can update the model so that the next time the element can be recognized properly if it wasn't being recognized. We've also separated the AI model from the installation in the latest version of our products so that you can get a new version of the model as it's updated. Just like in the functional test automation space, we also cater to all three personas in the performance testing space. For QA or performance engineers, we provide LoadRunner Professional for smaller project-based initiatives. When the initiative is larger or enterprise-wide, we provide LoadRunner Enterprise, which extends LoadRunner capabilities by including asset sharing and trend reporting. The asset sharing allows you to share lab resources, for example, load generators, controllers, the actual licenses themselves, and schedule and reserve them. Trend reporting provides a mechanism to analyze not just the current run, but how that run compares to previous runs to provide the larger picture of whether overall performance is improving or degrading from run to run. For me personally, when I was a performance engineer and ran a performance engineering group, our performance engineers spent anywhere from 2 to 4 hours creating this manual trend report ourselves because we were using LoadRunner Professional at the time. We also provide LoadRunner Cloud, where our SaaS provides all the necessary infrastructure for executing the tests at runtime in our cloud. Both LoadRunner Professional and LoadRunner Enterprise can also cloud burst out to LoadRunner Cloud for additional spike performance tests. For the developer, we have a relatively new solution called LoadRunner Developer. It's free. Let me say that again. It's free and can run up to 50 virtual users within the developer's IDE. It also has the ability to leverage Cloudburst credits to Cloudburst out to the LoadRunner Cloud directly from the IDE. They don't have to engage the performance engineering team. And they can execute it in conjunction with UFT Developer so that the developer can understand the impact of injected load on the actual end user. Additionally, since they all co-reside in the IDE, you can leverage the service virtualization capabilities we talked about earlier during the execution to enable performance and load testing, even when other parts of the solution aren't available. As you can see from the screenshot, we also leverage a Grafana analysis dashboard during the run as well, which is included with LoadRunner Developer. For the business analysts, we have a protocol called TrueClient that allows the business persona to contribute to performance testing as well. As you can see, the script is displayed in near plain English and allows most business analysts to create scripts that are anywhere from 80 to 95% complete. Then they can deliver those scripts for a final polish to the QA or performance engineering persona. Everyone should be contributing to performance, just like they should be contributing to functional automation. So let's drill back out and look at the DevOps pipeline. You've probably read multiple articles about DevOps from multiple sources, including consulting firms. Most of those articles extol the virtues of open source and suggest that you should definitely leverage open source solutions since they're free, air quotes again. Each box has multiple solutions that are viewed as open source. The challenge that is being faced in the industry is that free is only talking about licensing costs, not total cost of ownership. These quote unquote free solutions frequently require significant human labor investment in order to successfully accomplish the tasks that the tool is being asked to do. So for example, let's talk about Selenium. It requires detailed coding knowledge, intimate understanding of the object properties within the DOM, the document object model of your application. Only works with web, and its locators often rely on CSS and XPath. Many technologies will cause that CSS and or the XPath to change with each build of the artifact, causing brittle test automation scripts that require heavy maintenance and a lot of investment. Furthermore, the scripts are so technical that they're difficult to read and really only cater to one of the three personas that we've talked about. As with all open source solutions, when, not if, you run into a problem, you have to rely on the open source community for a resolution. If the problem's unique to your environment, excuse me, you're on your own to figure out how to resolve the problem. If the community hasn't encountered your technology before, you're also on your own. When you deal with a COTS or commercially off-the-shelf solution like Micro Focus Solutions, you're backed not only by a robust user community, but a support and R&D organization who can help you when you face these challenges and provide a much faster mean time to resolution and deeper and broader technology support. As with the case of Selenium, since you're limiting the personas that can contribute to the automation, you're also exposing yourself to the increased risk of defect slippage because you haven't accounted for those other personas through and their thorough processes and knowledge. But let's assume for a second that you've done all the necessary human labor investment and your pipeline is running smoothly and effectively, utilizing all of these open source tools. How do you make informed decisions about what's going on within that pipeline? We at Micro Focus provide solutions for each of these phases of the DevOps pipeline. While we wouldn't be opposed to a rip and replace approach to your pipeline, we really prefer to focus on plugging the gaps in your pipeline as they exist today. For example, if you tell us that you already have a team of Jenkins experts who have built and are maintaining Jenkins jobs and pipelines as the build system, that's great. And we can focus on filling other gaps. Maybe you need to plug the Git regulatory gap that allows developers to overwrite previous developers' comments without a history. We could lay Pulse Uno on top of Git to provide that immutable history while preserving the current way of working. Or maybe you aren't performing static code analysis, and we can help plug that gap with Fortify. Or maybe you're using a build system to also do deployment with lots of scripting, which requires lots of maintenance and a lot of the continuous human labor investment. We could help you by digitizing those scripts with deployment automation and stop forcing your build system to do something it wasn't purpose-built to do. There's still a challenge, though, that we need to address. There's actually a fourth persona that we haven't talked about yet. That persona is leadership and management. They need to be able to make informed investment and strategic decisions based on the information in the entire pipeline across all these different tooling. You're not going to have a director or a vice president scraping through Jenkins logs trying to determine what's going on within the pipeline. That's where ALM Octane comes in. ALM Octane gathers the information from across all of your DevOps pipeline tools, whether they're Micro Focus, open source, or third party, and provides reporting and dashboarding so that your leadership can make insight-driven business decisions, driving your DevOps pipeline to achieve its goals, which is delivering software at the speed of business with quality. So thanks for taking the time today to talk with us and listening to our point of view around testing needing to shift everywhere. I've included a hyperlink in here as well to an ebook that talks about integrating open source and COTS solutions and the value you can realize by doing so.